In this module, we're going to use Simulink to tune a PI controller on the temperature control lab. I want to point out briefly that within my working directory, I'm within this lesson 14 and then Simulink folder. That is so that all the relative paths between these different functions and the Simulink files are able to see each other as they're all within the same current working directory. I'm going to go ahead and I'm going to use the Arduino pi.slx file. If you have an older version of MATLAB, you may want to try the _R2014A Simulink version. We'll go ahead and we'll open that. There's a couple things we'll look at here. It's dragging everything over. Alright, this is our output here where we'll show our temperature among other things. We have our set point right here of 40, so I'll go ahead and double click. We can change the set point at any given time. And we also have our PID controller window. Let's see if we can get them all lined up. I want this one as well. There we go. So a couple different windows. What we're going to do is we're going to set the tuning parameters for our PID controller and look at how it responds as we change the set point, as we do a couple step changes. So we have two terms right here, the proportion term and the integral term. You'll notice that these are, it's different than our tau I or tau p per se, because it's the gain of that term. So it's, for example, the integral term would be the value kc divided by tau I. So we need to have both of those in there. If we go ahead, we'll go ahead and we won't even act like it didn't happen. Let's go back and look at lesson 14, what happened for the MATLAB version in the live scripts, what our tuning parameters were. So we had a kc of 5.9 and a tau I of 175. So we'll go ahead and we'll just implement those. The kc is going to be the part for the proportional term just fine, so that's going to be 5.98, about 6. In fact, we'll just say 6. For the integral term, we'll just do it right here in the command window, 5.9829 divided by 175. And we get 0.0342. So we'll go ahead, I'll minimize this, and we'll go ahead and we'll put this. Proportion term, forgot it already. So many windows. I remember now, it was 6. Sorry about that. So this was 5.98, and this was 0.03. So we'll go ahead, and then one other thing that Simulink includes is this automated tuner, if you have a good function that it can call. So PI tuning, we're going to form parallel, so we're going to go ahead, hit apply, say OK, and now minimize some of these windows we're not using, and we'll start our step test. So we'll go ahead and start running Simulink. We'll check out this error real quick because I haven't seen it before. I figured out it's because I moved out of this active directory. So I'm going to go ahead, close out, move back to Simulink. We're going to try running again. You'll see this time it's initializing. That active directory stuff, it's stuff you don't really think of as an engineer, but it's stuff that makes a difference for your programming, so it's good to be aware of. Go ahead, look at our temperature. Have our Simulink up. It looks to be connected, which is good. And we have a set point of 20, which is lower than our current temperature. So let's go ahead, we'll hit to 52, And we can see now we're recording data. We'll make that a little bit bigger. So our temperature was pretty high because it didn't know what to do. In blue, we have our heater turning on now. And in red, I believe we have our heater, or our temperature, I should say. Or perhaps, actually, I believe blue is our heater. Sorry, blue is our temperature, red is what the heater setting is at, and yellow is our set point. Nice thing about Simulink is we can control things in the moment. It's kind of fun. So let's just set this now to 60 like we did for our MATLAB project, or our MATLAB live script. You can see right there that jump is why we take the derivative with respect to the process variable and not the error. Either way, Simulinks you actually use quite often in industry. Simulink and MATLAB are used quite a bit, and Simulink especially is able to work real well with hardware systems and kind of model real-world systems and control them in a way that's convenient for engineers. So experience here will definitely help you. You can notice some bouncing up and down as we have some instrumentation area. You know, our thermistor is only able to record temperatures so well, so there'll be a little bit of error. But hopefully this does a good job of showing you how to use the Simulink modules, and also shows you some of those common errors, especially the current working directory is a big one that people run into. You can see it's approaching the set point, and we'll let time go on. I'll go ahead and pause the recording, we'll let it finish, and we'll discuss the results. Alright, there we have it. I went back and I looked. It turns out I was right the first time. The red line is our temperature, so we can see we're staying pretty close to that, just a little bit off, but we can see that our heater is slowly marching upward to counteract that persistent offset. We have the heater moving up and down due to measurement error, but getting closer and closer. We can, again, similar to the last time, we can try this with multiple tuning settings and be able to find a setting that we like. But we're able to hopefully demonstrate here how to use Simulink with the temperature control lab as well. Let me know if you have any questions. I hope you had a good time.